Hi friends, Michael Fudge here. I would like to welcome you to another episode of Mastering the SQL Select statement. As always, I thank you for watching and hope you find these videos helpful. In this part 8, we will deep dive into window functions. These help simplify our queries by allowing us to take a second pass over the result set to either find, summarize, or rank values. Here's the basic syntax of all the window functions. First, we start out with a window function itself, then we have an over clause, and in parentheses, we specify how we want to partition it, that is, which columns we want to sort of group or organize the window function by, and then the order by is applied within that partition how the data might be sorted. And there are certain window functions that require the data to be in a certain order for them to make sense. You will find that the window functions are in the projection. That is, they come after the select statement. So after we join and use where and use group by and use having, we have that common table expression, that result set. And then we use this window function to go over that result set again. And we apply the window function usually to each row in that result set. There are basically three kinds of window functions. There are window functions that do aggregates, similar to the aggregates that you learned when we did group by and having, except these aggregates will get applied to every single row. There are value functions which will find and return a specific value from the partition, like maybe the first or the last or the next or the previous. And then there are ranking functions which allow us to take our data within our partition and arrange it in a certain order. So we could use things in the ranking functions to figure out what quartile or what upper half or lower half the data might fit into. So those are basically the three types of ranking functions. We're going to look at all three. I don't know if I can show you everything there is about all the window functions, but I'm going to try. Okay, I'm out here in Azure Data Studio, and in true cooking show fashion, I have prepared by writing a query already. And this is, in fact, the same query that I finished off the previous video on common table expressions with. And basically what this query does is it gives you a list of student name and the year name and the GPA. And then it combines that with another common table expression that figures out what the average GPA is by student name, and then associates that in the final query with the row where the student year name matches the student year name from the other query. So we join them together that way. And then that way I get the average GPA by year for each year name. The reason I bring up this query is this is typically a query that you would write using a window function, and it ends up being a heck of a lot easier to represent this query as a window function. You don't have to write, 19 lines of SQL to do it. This is sort of why I would like to think, anyway, that window functions were created as part of the SQL standard, was to simplify common queries like this and avoid us to having to do this unnatural feeling join where we join on two columns that are not primary and foreign key. So let me get into how this might be written as a window function. So starting out, I'm going to use what are called the aggregate window functions. And I'm just going to go for it, rewrite this same query as a window function, and then we'll sort of talk about and explore other possibilities with window functions. So, start out with a select star from students, and I'm going to bring in this information because this is what I want. This is half of the query already. Now what I'm going to do is I'm going to have something here. I'm going to do something here. And that something here is going to be the average student GPA by year. That's what I'm going to do right there. Just stick it right there. Because you're going to be impressed with how this works. So the window function that I want to use is I want to average the student GPA. Now, normally when I do this, it's an aggregate, and I need to then group by all of these, and I lose my row level query that I had before. But with a window function, remember what it's doing is it's taking the result set, that is, it's taking from students, and it's going to make a second pass over it and apply the grouping that I specify. So I'm going to say average that over, and then I want to partition by student year name. So that's going to make a second pass over the data, in essence, grouping it by year name, and then applying this aggregate. And then that result set is going to be in every row in the original query. So check it out. And this, believe it or not, is the same query as this up here. It's hard to believe, I know, but it is true. I'm going to zoom it out a bit so you can get a big sense of it. So what I have highlighted on 5 through 19 is the same as 22 through 24, and they actually execute the same. If you were to look at how the DBMS runs this query and how the DBMS runs this query, you will see it uses the same logic to do that, even though we wrote them very differently. The best way to explain what a window function is doing is we have this student table. This is our common table expression. We're grabbing this, we're grabbing this, we're grabbing, it's all straightforward. When we get down here, what we're saying is for each row, what I want you to do is take that row's year name, which is freshman, and I want you to find all the other freshmen and then give me the average GPA over those freshmen, and then present that information right there in the attribute, the row column intersection. So you'll notice that every single freshman has the same average, which is exactly what we would expect. And then when the value switches to graduate, this is the overall average from graduate. So that's how window functions work. They're extremely powerful because they allow us to take like 2 passes over our common table expression rather than just one. The same thing we did here. This is pass number 1, and then this is pass number 2, and then we're joining them together. That's basically what this is doing for us. So let's have a little fun with window functions just to show you how flexible they can be. Because you now know you're taking multiple passes, you can produce some pretty interesting reports using window functions. This is going to give me the average. I'm going to take exactly what I had here. You don't need me to retype that. I want to do it by year and by major. So here's by year. And let's add the major name in here. Major ID. And then I want to say, give me the average student GPA over this partition. Cool. And you might say, Mike, how is that possible? Well, of course, I have to have student spelled right. Having student spelled right is probably a good idea. You might say, Mike, how is that possible? Well, first of all, what are we looking at here? Pterodactyl, junior. Pterodactyl's GPA is 2.3. The average across her major is 2.76. The average of all juniors is 2.7. That's what you're looking at. This is actually taking 2 passes over the data. The first pass, well, it's actually taking 3 passes over the data. First pass just grabs, each row. Then it takes 2 additional passes. The first pass is organizing it by year name, freshman, sophomore, junior, senior, grad, and then calculating the average student GPA. The second one is organizing it by major ID, 1, 2, 3, 4, and getting that GPA. So in a single query, I can produce some pretty sophisticated results that I would normally require several subqueries and a common table expression with width to do correctly. So that's really one of the big values of using a window function. And I can continue to add even more window functions. Maybe I want to get the overall average regardless of whether it's by GPA or year. I can just add that in here. I can say average student GPA over the entire data set. Don't partition it as overall average GPA. Now I got a third additional pass I'm making over the data, where I'm calculating not only the average by year and the average by major, but the overall average across all 31 students in the data set. Really powerful what you can do with these window functions. Now, the aggregate window functions, there's counts. I can change all of these to counts. Doesn't matter. They could be counts, they could be averages, they can be sums, they could be a combination of averages, counts, and sums. You can really sort of mix it up and do kind of anything you want or need to sort of solve the problem. That's really where the beauty of window functions comes into play, is very little limitations over what you can do. If you can imagine it and you can think of a way to partition it, then you can do it. I do want to point out as well that this is all join friendly. So, for example, let's take a look at this example with a join. Student major ID, student major ID. Okay, there's my join. Set things up. Now, what I want to do is I want to produce a report that lists most everything from majors, like this. Okay, that's all the major stuff. And now, for each major, well, actually, I probably want to do, like, maybe I still want to do student stuff. Let's list the major name with the student, like this. Student first name, student last name, and major name. There we go. And now let's do this. Let's get a count of students in that major. Count the rows over partition by, whoops. Ooh. There we go. Partition by, and you can partition by anything. Major ID, major name, major code, doesn't matter. My point in this example is to show you as count in major. Point of this example is to show you that when you do a join, you can include, whoop, I got to put a comma there. You can include any values from, this common table expression in your partition. They're all fair game. Whether you include them in the projection or not, doesn't matter. They're all fair game. Okay. All right, let's take a look at some value window functions. Value window functions are have names like lag and lead and first value and last value. Now, where might you use these and how are they used? So let me take a look at the students table and let's order it by GPA, just to get an idea of what we're doing here. So the lowest GPA is Lily Pads. And then the next lowest GPA is Leave Me Home. But he's a junior and she's a senior. So let's order it by student year name, then student GPA. So now you see that the lowest GPA as a freshman is Victory Dance, and the next lowest is Buck Naked. Let me give you an example of using lag and lead. So I'm going to add a column here. I'll keep star here, and let's say lag student GPA over. Now you can include a partition or you could not, but you definitely need an order by because you need to say how you want the data to be sorted. So what I'm going to do is I'm going to partition this by student year name. And then I want to order it by the student GPA. Now, I included the order by here just so we can see what's a what, right? But this lag function, this is a separate order by that occurs on the second pass over the data after the common table expression is created. And then this is the final sort. I can leave this out, but I'm going to leave it in so you can just make sense of what you see. So you see that Victory Dance has no freshman with a lower GPA than him. So it's null. Buck Naked, that's Buck Naked's GPA, and there is one GPA that's lower than his, and it's this one, and that one is Victory Dance's. So that's basically how the lag function works, is it gives you the previous value over that partition and sort. So you can use lag a lot with dates, right? So if you want to find out what the last customer order was, you can use lag to retrieve that. You can say, here's their current customer order, and it was $50, and then here's the last customer order. I can include their GPA, and I can also include their name if I want. Say, as prev student GPA, and then I'm going to add a lag student, let's just do their last name, over the same partition, and group, or and order, as prev student name. And it's lag, not lab, Mike. Lag. There you go. So not only can you get their GPA, but also their name. It's Victory Dance. Or Oliver Stuff is missing. Who's the person behind him in GPA? It's Lola DeBrigida right there. Lola DeBrigida. See, I sorted them this way so you could see it much easier. But I don't have to sort it this way. I could sort it, and I can order it by anything I want. I can go back here and order it by student ID. Then it's really hard to find. Remember, it's still Lola DeBrigida, right? For Oliver Stuff is missing, it's Lola DeBrigida. Let's take a look. Oliver Stuff is missing. Way down here, still Lola DeBrigida. It's just the final sort is different, right? So these sorts are independent, and they can be any way we want. So like if you lag and order by in descending, you're actually going to get the highest, right? But there's also a function for that. There's a lead, so lag and lead. There's also first value and last value. If you sort, you can ask for the very first value, or you can also, in turn, ask for the very last value in the set. For example, we might want to present something called the guilty report, which lists the student names and by major, and the name of the highest GPA in that major. So it's going to list all the students, then their major, then it's going to list this is the person you want to be in that major because they have the highest GPA. To ease our pain as we start this one out, I'm going to grab this from statement, and we're going to start out. All right, that sets the stage. And we want student, first name, student, last name, major name. Okay, that's the basis of it. Now I want to use last value to get the person with the best GPA within that partition of major. So I'm going to say last value, student first name, over major name, order by student GPA as best student first name. Likewise, let's do their last name. I forgot my partition by, all right? I'm always afraid to type partition by because of how horrible I am at typing the word partition. So I'm going to paste in partition by so I don't have a cringeworthy moment. It's probably too late for that now. And let's change this to last name. Last name. And I'm going to break this up a bit so it's easier to read. And this is going to say best student last name. So this is going to show me a list of students and their names and then who I want to emulate because they've got the best GPA in that major. And not show their GPA, but show their names. So doors closed, best student in accounting, doors closed. Okay, this didn't seem to work the way I wanted to, did it? Because why is it showing that student in there on that partition? I think it's because of the sort order. I want first value, not last value. First value. That's what I want. All right, so that makes more sense. And just to show you that it does work, let me add the GPA in here so that you can see. Again, this is a silly report without showing the GPA because then you don't know why you're seeing, can you trust that doors closed is the smartest person in accounting? You need to see their GPA. So, well, no, doors closed is a 3.1 and Robin Banks is a 4.0. So this shows me the worst. Okay, so I want to do last value. And then this should be ordered by descending. Or is it first value? I don't know. We'll try them both ways until we get it. Sometimes this is what it takes because, honestly, it's a little bit to think about. So that is not the way I want it. I want to use first value and order it by descending. There we go. And then I finally have it. Okay, so there we go. So Robin Banks, and then who do you want to emulate? Robin Banks. And then ginger beer is the best, and all these people in applied data science, they got to look up to ginger beer. And validation is the best. Okay. So, yeah, it took me a while to get it, but I got to be honest with you, I'm pretty experienced with this stuff, and it still takes me a while to get it. But it's important to be able to figure out how to make the query correct and know when the query is not correct, right? And it was very difficult to do that without showing this because I don't know who the best is, right? So now I know Robin Banks is a 4.0 in accounting. That's just straight out of the from clause, right? Straight column projection. And now I understand this a little better. I'm sorting the GPAs in descending order. So the best one is first, and I'm grabbing that first value. That makes sense. Okay, let's finish up by looking at the last group of window functions. Okay, and these are the ranking functions. So maybe what you want to do is take the students by GPA and put them into a quartile, for example. This is a very useful window function. And I'm just going to grab the same things I did before. And I'm going to take out major name and put in, we'll just leave students. That's fine. So now you have students their name and their GPA. And now what I want to do is I want to get a entile. And what do I want? A quartile, we'll say, over the entire data set, order by student GPA, descending as quartile, GPA quartile. See how this works. These 8 students are in the first quartile. That is, if I take them all and sort them, and I split them in half and then split that in half, right? These are the top quartile of students, and these are the bottom quartile of students. I can actually split them out. Entile is, I can split them up into, I don't know, 10-tile. I don't even know what a 10-tile is, but I can do that. So those are the 1s, those are the 2s, 4s, 5s, 9, and 10s. So that's how ranking functions work. One of the very popular ranking functions that we use is row number. It allows us to generate a unique number for each row in the output. For example, and then let's, in the front of that, let's put row number over the entire data set as row num. I mean, this is a way to generate a unique ID slash surrogate key. Oh, I need an order by. That's right. So let's order by student GPA. This is a great way to generate a unique ID for every row in the output. See that? Just to show you that it does work exactly the way you expect. Maybe I want to do a row number, but I want to do a row number over student GPA. Let's do a row number over something that repeats, student year name. See, I still get unique numbers, even though the values repeat, right? They just get sorted in this order first. So row number is always going to generate a unique number. Now, excuse me, that takes me back to entile. What happens if, so this is row numbers. So what happens when I use entile with a partition? What does that look like? Let's partition by student year name, and then order by that. And let's just use, quartiles. Again, I think we all understand quartile. And this will be GPA quartile by year. Let's take a look at this. So you'll see, I'm violating the first law of queries. I better put student year name in there or else it's not going to make a lot of sense, right? So within the freshmen, these 2 are in the top quartile. These 2 are in the next quartile. These 2 are in the third, and then this one's in the bottom quartile. So you can break up the entile, if you will, by partition. So all the ranking functions work that way, by the way. So let's finish with this example. Suppose you're tasked with doing the following. Student report of GPAs by year name. Nothing we haven't done before. But show class rank. Ergo, highest GPA is a 1. Next highest is a 2, etc. So select. A lot of this is going to repeat. I'm going to grab it from students. Now I'm going to use a different window function for this one. I'm going to use the rank window function. Rank student. I think it's just rank. over partition by student year name order by student GPA descending. Here we go. So Robin Banks is the top freshman, and Victory Dance is the 7th best freshman by GPA. Likewise, if I go down here, Jack It Up is the best sophomore by GPA, and the worst sophomore, the 7th best sophomore in this case, is Dandelions. So that is the rank function. So again, there are different kinds of window functions we can use. There are ranking functions, there are value functions, and there are aggregate window functions. And you can see that anytime you do a window function, it is taking an additional pass over the common table expression that results from the from clause or the group by or the having or the where. After all that's done, then it applies this function. You can mix and match these. I can use rank with one of these other functions up here. I can use the ranking function with a value function or with an aggregate function. So it's really up to me, and it depends on the problem that I'm trying to solve. Extremely powerful, extremely useful. That's window functions.